when finding the area of a triangle, it's important to know that the height of the triangle is actually the altitude. So if you look at the formula for area, and you will be given this formula, I feel like we know it pretty well, but you will have this. You don't have to worry about memorizing it. But the area of a triangle is just 1/2 base times the height. Well, B stands for base and H stands for height. So the area is in that box. You will have it. You don't have to worry about memorizing it. Okay? I like to think the base is kind of the bottom of your triangle, and the height is the altitude of a triangle. So if you remember, the altitude of a triangle starts at a vertex and drops straight down, and is perpendicular to the opposite side. So the height of a triangle is actually its altitude. So there are different types of triangles, meaning they have different types of altitudes. So we take a look here. The height of an acute triangle are always inside the triangle. So the altitude of an acute triangle is always inside of it. Okay? In the diagram number 1 below, okay, the height of this acute triangle is FA. So we go to the vertex, we drop straight down, there's our height. So if we were to find the area of this triangle, it would be 1/2. The base is BC. Okay? I also like to think the base is the side that the altitude is touching. Okay? So the base would be BC times whatever our altitude is at that. In an obtuse triangle, the height is always on the outside of the triangle. When you have an obtuse triangle, the altitude or the height is always on the outside. Okay? So we take a look at this diagram here. The height or the altitude of this triangle is CT. It's always on the outside. So you go to that kind of vertex that's hanging over the base, and you drop straight down. And that is the height. So if we were to find the area of this obtuse triangle, be 1/2 the base, which is BA. You notice the base doesn't touch the height. That is okay with obtuse triangles, but it's the base, so the bottom of the triangle times the height, which we said is CT. And in right triangles, the height is always one of the legs. Okay? The legs are the two sides that make up that right angle. Okay? When we find the area, we don't really use the hypotenuse of a right triangle. It's always the legs. So in this diagram here, the height of this triangle would be AB. That's the one that's going up and down. Okay? The base would be the other leg, which is BC. And if you get them mixed up, it's not the end of the world. You'll still get the same answer. So if we were finding the area of this right triangle, it would be 1/2 the base, which is BC, times the height, which is AB. Questions over that? We'll do some examples, and we'll see how this works in the coordinate plane. So we take a look here. We're going to find the area of each triangle below. Alright. So write down the formula for area of a triangle. Look at your formula sheet. Area equals 1/2 base times the height. So you just have to fill in what your base and what your height is. 1/2 something times something. Well, looking at this triangle, what is our base? What's our base? 16, yeah. It's the side. I like to also think it's the nice flat side of our triangle. So there's our base, it's 16. What's our height? In other words, what's our altitude of this triangle? 13, yeah. Go to where that altitude is. That is your height. The height is 13. And you notice it is an acute triangle, so that height is on the inside of the triangle. The base is always one of the sides. And I like to think it's the flat side, the slanted side. Then all you have to do is just plug that in your calculator. 1/2 times 16 times 13. And what is 1/2 times 16 times 13? What is it? 104. And there you go, 104. When we label We say feet what when we find the area? Feet squared. So when we have units, it's that unit squared. Because it's 16 feet times 13. I think x times x is x squared. Foot times a foot is 3 foot squared. 3 squared. Questions over that? Look at this one. What type of triangle is this? I see my triangle right here. Is it a right triangle? Is it a acute triangle? Is it an obtuse triangle? What type of triangle is it? Obtuse. So where's our height on an obtuse triangle? Is it inside the triangle or outside the triangle? Outside. Right? So we're trying to find the area. Area. 1/2 base times the height. When looking at our triangle, what's our base? What's that bottom flat side of our triangle? What is our base? Yeah, just a flat side. Here's our base. The bottom part of our triangle. It's 10. What's our height? What's the height of this triangle? 8. Yeah, the height of an obtuse triangle is always the one that's just, you go to that, kind of that vertex that's hanging over the side, and you drop straight down. The side's hanging over, there's our height. Right? And then you just plug that in your calculator. What is 1/2 times 10 times 8? 40. How would we label it? Inches what? Inches squared. And these are not drawn to scale. It's not really 40 square inches. Hypothetically, if it had those dimensions, that would be area that would be. Questions over that? If we take a look at this one, what type of triangle do we have here? Oh, right triangle. So we know our height and our base are going to be the legs of this right triangle. So, formula. Base times our height. What is the base of this triangle? Good, it's 7. Here's our flat part. Right? What is the height of our triangle? What's the other leg? And again, if you got them flip-flop, that's okay. You'll get the same answer. What's 1/2 times 7 times 10? So the area of this triangle is 35. What? How would we label it? Questions over that? Not too bad. Pretty basic stuff. Alright? Reviewing that a little bit to help us find the area in the coordinate plane and to help us with the next one. This one's a little bit more trickier. We want to find the area of triangle JKL. Round our answer to the nearest 10. Okay? Well, I'm finding area, so I'm going to write 1/2 base times height. That's my formula. What is my base of my triangle? What's the base? Yeah, 5. And if it's confusing too because it is tilted, just redraw it not tilted. And 5, this was K. This would be J, and that would be L. You can rewrite it not tilted if that helps. Or turn your paper so it's not tilted. Okay? So we know our base, the bottom part of our triangle is 5. What's our height? What's our height? Or which side is our height? Which side would represent our height in this one? Which side would represent our height? Take a stab at it. One more time, get back to the flow. Yes. Yeah, it would be LK. What's the problem here? LK is our height. What's the problem? It didn't give us our height, right? It's not 10. 10's the hypotenuse. We never use the hypotenuse for area. We only use the legs. So we don't know what our height is. We have no clue. Okay. Well, is there a way we can find our height? What type of triangle is this? The right triangle. Is there something we can use to help us find the missing side of that right triangle? Pythagorean theorem. So sometimes your piece is missing. Sometimes it's not as easy as that first example. Sometimes you need to do some math to find a missing piece. In this case, we need to find our height. Little helpful hint. If you're finding area and you're not given the height, more than likely you're using the Pythagorean theorem to find it. Okay? Helpful hint. So, label. I'm going to start at my 90-degree angle, go across. That's always my C. Then it doesn't matter. I'll make that my A. I'll make my height my B. And then you plug into the Pythagorean theorem. So we have 5 squared plus our height, we don't know what that is equal to 10 squared. And then we just have to solve for our height. Well, what is 5 squared? 25. What is 10 squared? 100. Move this 5 over. What is 100 minus 25? 25. Good. And then what do we need to do to both sides? Square root. Do we want to round right now? No. Nope. No. Talked about that Friday. Do not round till the very, 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 very end. So it might seem a little weird, but we're leaving our height as radical 75. Okay? So there's our height. Leave it as radical 75. Then when we plug this in, then we can round. So I'll use my graphing calculator. You just do 1/2, and then you could do 0.5 as your 1/2, or I would do alpha equals enter 1/2 5 times 5 times radical second x squared 75. Type it in like that. Okay? And when we plug it in, we get a decimal. Direction said round to the nearest tenth. So we round it to 21 point what? 21.7. So roughly, about, approximately, so that's the approximately symbol, 21.7 inches squared, since we found the area. Okay? You have to be very careful when plugging this in your calculator. So plugging it in your graphing calculator. If you do this, it might give you the right answer. I'm not sure. Sometimes it gives you the wrong answer. You still get the right answer. So you could type it in like that. There's some instances, if you do that all in one step, you don't always get the right answer. So just be careful. But it's because we put the 1/2 first. If you put the 1/2 second, then it gets messy. So, there we go. You can type it in either way. I was nervous if you didn't put parentheses around it, you'll get the wrong answer, but we're good. Questions over that? No? Well, when you're finding the area of triangles in the coordinate plane, it's the same concept from example 1. Okay? You have to just find your base and find your height. Except it's not given to you. Okay? It's just graph. But your height and your base, you'll realize, are nice and flat sides. So if you can count, you can easily find your base and your height. Okay? So take a look at this first example. We want to find the area of these triangles below. So I'm told to find the area, so I'm going to write down the formula for area. One half something times something. Well, what type of triangle? Here's my triangle. I'm going to highlight it a little bit so you can see it a little bit better. What type of triangle is this? A right triangle. So our base and our height are just the legs of that right triangle. Okay? What's my base, or what side is my base? What's the base of this triangle? I think the bottom. Well, the length is 4, side BC. So here's my base, 1, 2, 3, 4. Here's my base. And when we count, we get 4. What's the height? 3. My height is this side right here, AB, and when we count, it's just 1, 2, 3. The only difference is from example 1, you literally just count. That's all you have to do. Find your base and your height by counting. Plug in your calculator. What's 1/2 times 4 times 3? There's no particular units, so just write it as units squared. Not super picky if you forget that. Technically, because there's no specific unit given, we just say units squared. And there you go. Okay. So we take a look here. Here's my triangle in this one. What type of triangle is this? Is it an obtuse triangle? Is it a right triangle? Or is it an acute triangle? Acute, right? So where is the height in my acute triangle? It's on the inside, right? So I'm going to go to this top vertex. Okay? I'm going to go to that top vertex. And it might also help too. Which side is my base? The bottom one, right? Here's my base, LM. Identify your base first. Okay? To get your height, because the other one, it was drawn nice and neat in there for you in the picture. Here we have to figure out, well, what is my height? So identify your base first, and go to that vertex opposite of your base, and drop straight down. That is your height. Okay? So go to your base, go to the vertex opposite of your base, and go straight down. That's your height. So when we're trying to find the area, area equals 1/2 base times height. When we count, what is the length of our base? 4. When we count, what's the length of our height? And we plug that in. The area of 1/2 times 4 times 5, my area is what? 10 units. We take a look at this one. What type of triangle is this triangle? Cute, right? It's obtuse. Where is my height on an obtuse triangle? It's on the outside. I have to say it so aggravatedly. Okay. We can be nice when we answer questions. So, again, to find the height, you go to that kind of overhang angle. It also might help identify your base. Which side is my base? Which side is my nice flat side? And then the coordinate plane is nice and flat. It's not slanted. Okay. Which side is my base? UV. Here's my base. Go to that angle opposite of your base, and it's that angle that's overhanging, kind of going, it's going past the base. Okay? Go to that vertex, and you literally go straight down. That's your height. It's dropping straight down from that angle that's kind of going over the base. It doesn't have to connect with your base. Okay? When we count, when we find the area, find the area. What is the length of our base? What is it? 5. This is painful. I know we had 5 days off, but I know we all can count. Pretty easy stuff. We can count to 5. Okay? Getting a little rough. Let's participate. Let's answer some questions. What's the length of my height? 5. 1, 2, 3, 4, 5. Very good. Your base is not 6. You don't count all the way to your height. You literally count what the base is and you stop. You don't go extra. Okay? You know, that happens a lot. We might do 1, 2, 3, 4, 5, 6. It's not 6. It's just 5. Plug that in your calculator. What is 1/2 times 5 times 5? And if you work ahead, just give me the answer. A lot faster. What is it? 12.5. So we would say it's 12.5 minutes squared. Question. If we take a look at this next one. So again, this triangle is tilted. Here's my triangle. Which side is our base? Yeah, FD. Again, if it helps, take your paper and just turn it so your triangle is straight up and down if that's confusing. Okay, just turn it so the base is horizontal. Okay, if that's tricky. So here's my base. Again, this is an acute triangle. So I start at my base and I go to the angle across from it. And I just follow that grid line straight down till you get to your base. That is your height. That is our height. And we just plug it into the area formula. When we count, what is the length of our base? 5. What's the length of our height? 5 seems to be the magic number today. And then we did this on the last problem. What did we say? What's 1/2 times 5 times 5? Questions over there? The hard part about this is finding your height. And if you notice, did we do the Pythagorean theorem at all? In these problems? No. Your base and your height are always vertical and horizontal straight flat lines. Your height and your base are never slanted lines. Okay? So, I see this a lot. We use Pythagorean theorem to find our height. Your heights are always nice, flat, and straight. You should always just count to find them. You should never be doing the Pythagorean theorem in the coordinate plane to find your base and your height, your area. Use the Pythagorean theorem to find perimeter. Never use Pythagorean theorem to find area in the coordinate plane. Okay? When it's not in the coordinate plane, you're going to use Pythagorean theorem. You'll see some examples, right? Below. But when we have problems like this, it's literally just counting. That's all you have to do. Your base and your height are always nice and flat. Nice and flat. Okay? If we take a look at the last few examples, it's important to note that the height of an equilateral triangle bisects the base of the triangle, meaning it cuts the side it's intersecting in half. The same thing goes for isosceles triangles as well. Okay? In diagram number 4 below, the height of an equilateral triangle is AD. So it's here. Right? Because it's an equilateral triangle, it's also cutting this bottom half in two, cutting it in half. Right? So that should be a B, sorry. BD and CD are the same. Okay? Important to know. Same thing with an isosceles triangle. In the diagram number 5, this is an isosceles triangle and the height is AN. Well, because it's an isosceles triangle, the height is cutting that side in half. So BN and CN are the same. That's important to remember for these next two examples. So take a look at these two examples. We want to find the area of an equilateral triangle below. Round your answer to the nearest 100. Okay? Well, what's special about an equilateral triangle? What makes it equilateral? Yeah, all the sides are the same. So all the sides are going to be what? Based off this diagram. 12. They're all 12 yards. Okay? Equilateral triangle, also an acute triangle. So the height is inside that triangle. So we're finding the area, 1/2 base times height. Okay? What's my base? 12, right? Can't really go wrong. It's is bottom side. Always like to think of the base as the bottom. So I know my base is 12. Here's my height. I go to the side across from my base. I go to that angle and drop straight down. Here's my height. The height is always perpendicular to the base because it's an altitude. Altitudes are always perpendicular. Okay? What's the problem? What is our problem? Do we know what our height is? No, right? We drew our height, but they didn't tell us. It wasn't drawn in there for us. We don't know what it is. Okay? But what do you notice here? What type of shape did we just draw by drawing in our height, by drawing in our altitude? The right triangle. What do you think we can do to find our height? We know that's a right triangle. Pythagorean theorem, very good. Again, when your height is missing and you can't easily count it in the coordinate plane, you're going to use the Pythagorean theorem to find it. And if it's helpful, you can redraw this triangle off to the side. No shame in that. Okay. We know this side right here is 12. What's the length of our bottom side? 6. Yeah, we said because it's an equilateral triangle, the height is cutting that bottom side in half. It's hitting it at its midpoint. Okay? So if all the way across is 12, well, halfway would be 6. So this is 6. This is also 6. Okay? And we're trying to find our height. So then we can just use the Pythagorean theorem to find it. So I'm going to start at my 90-degree angle, go across. That's my C. I'll make that A, make that B. It doesn't matter. But your hypotenuse has to be your C. When we plug it in, we have A, which is 6. We don't know B, that's our height. And our C is 12. So we just solve for our height. What is 6 squared? 36. Well, that's H squared. What's 12 squared? 144. To get H by itself, we have to move that 36 over. What's 144 minus 36? 108. And then what do we still have left to do on both sides? Our height is not 108. What do we still have left to do? Square root. Don't forget that step. So our height, again, just leave it as radical 108. Don't round yet. Round is 10. So we know our base is 12. We know our height is radical 108. Now plug that in your calculator. 1/2 times 12 times radical 108. It said round to the nearest hundredth. How many decimal places is 100? 2. So round it to 2 decimal places. When we round this to 2 decimal places, it's what? 62.3 what? 35. Yeah, that if you go to 5, go next door, it's less than 5, so it keeps it the same. So 62.35. So our area is about 62.35 yards squared. Questions? Same thing goes for isosceles triangles. We want to find the area of this triangle below. How do we know it's isosceles? What makes it isosceles? Two sides are the same. Very good. These two sides are both 12, so therefore they are the same. So I'm finding area. I'm going to write my area formula down. What is the base of my triangle? My nice flat side. Yeah, 7. There's my base. Okay. It's an acute triangle, so I go to my base, I go to the angle across from it, my height is written in there nicely for me. What's the problem? So how can we find it? Pythagorean theorem. Okay, this is my height. I I have my right triangle here. And again, if it's helpful, draw it outside your triangle. Sometimes it's with all that written all on top of each other. Here's my height. I know this is 12. What's the length of my bottom? What is it? 7. You're right, all the way across is 7, but we're only looking at this part. And just like equilateral triangles, the altitude is cutting that base in half. So it's half of 7. 3.5. So this bottom part is 3.5. And this is my right angle. So label, go across from your right angle, that's your C. I'll make that A, make that B, and then plug it into the Pythagorean theorem. So we're going to do A squared, which is 3.5, plus B squared, which is my H, equals C squared, which is 12. What is 3.5 squared? Don't round, keep it as the decimal. What's 3.5 squared? What is it? 12.25. 12.25. Yes, don't round that to 3. 12.3. Keep it as 12.25. Keep it accurate. And then we said 12 squared on the last one was 144. Move that 12.5 over. Or 12.25. We get h squared is equal to, what's 144 minus 12.25? Is 144 minus 12.25? 131. 131.75. Again, square root. Don't forget to square root. And do not plug it in and round. Do that at the very end. It looks a little weird, I know. Leave it like that. Right? You might round incorrectly, which then will throw that rounding off. You might round, but then it throws the accurate answer off. Do not round to the very, very end. You will take off points if it does not match perfectly. Okay? Plug it in. That's our height. It looks a little weird, I know. But leave it like that. And then you just plug that in your calculator. 1/2 times 7 times radical 131.75. What did the directions say to round to? Nearest tenth. If we round that to the nearest tenth, it'd be 40.2. This is 1 decimal point. So it's roughly 40.2. Yes, hang on 1 second. Questions over that? No? Okay. Was that our last one? Alright. You can flip it over to the back. There is your practice that you can work on.